Hello everyone and welcome to this Azure Festive talk. So first things first, Merry Christmas and Happy Holidays to you all. I hope that you're all able to have a good break and I hope that you are all keeping as safe as possible in the current conditions. So quick introduction of myself. So my name is David Okeyode. I am a cloud security consultant at a company called Palo Alto Networks. So I work in the speedboat team of the Prisma cloud solution at Palo Alto Networks. So I have over a decade of experience in cybersecurity. I've been doing this for more than 10 years. I have over 6 years of experience as a Microsoft certified trainer. I've also authored popular online courses for the Cybery platform. For those of you that are familiar with that platform, I've authored courses on cloud security. I'm also a Microsoft Azure MVP. I have a bunch of Azure certifications, as you can see on the screen. But the main thing is I just want to pass across some what I think will be useful information for some of you to be able to understand the perspective of offensive security when you're doing your security design in Azure. So let's look into the agenda of what I'm going to be covering today. So I'm going to start by just giving you a brief introduction as to why I'm taking this different approach when it comes to cloud security education. So a lot of the talks that I do more recently focus on the offensive side of cloud security, and that's by design. That's an intentional thing. So I'll also talk to you about the Azure rules of engagement. That's the beginning place whenever we talk about offensive security. We do not want to get ourselves into trouble. I'll show you an Azure attack matrix. I'll show you the MITRE attack framework for Azure, but I'll also show you my Azure attack matrix that I came up with, or one that's constantly evolving. We'll talk about some credential theft scenarios. I'll show you some nice demos on some Azure specific tools, which are MicroBurst and StormSpotter. And at the end of that, I'll conclude by talking about Prisma Cloud Compute Solution or Prisma Cloud Solution and how it can help you to defend your Azure environment. So I hope that you're going to get some useful information out of all of this. So to begin with, let's look at why I'm taking a different approach when I'm talking about cloud security. So the number one reason is that there's a lot of presentations and talks and videos that focus on Azure security best practices. I mean, you can go on YouTube right now and type in Azure security best practices and you come up with a lot of very wonderful talks. Also, you can go on the Microsoft documentation website, right? docs.microsoft.com, and you find very, very good documentation from Microsoft on best practices for different Azure services and for the Azure cloud platforms itself. You have the cloud adoption framework documents that Microsoft put out. Again, very wonderful documentation. So there's a lot out there already when we're talking about how to use services and best practices, right? But there's not as much out there when we talk about the offensive side of cloud security. Also, understanding attacker behavior is an important part of cybersecurity education. We know this with traditional security, right? That's why we have disciplines like ethical hacking, offensive security, where we have certifications that are geared towards those, because that's an important part of cybersecurity education. Being able to see things from the perspective of an adversary can help you become a better architect when you're designing your solutions in Azure. So rather than just seeing just general best practice, being able to think and see how an adversary will approach your systems when they look at it. Like what somebody rightly said, architect and administrator thinks in terms of lists, but an attacker thinks in terms of graphs, how are things connected. And it's important for us to see that perspective when we're designing our solutions on Azure. And it's also important for us to learn what not to do from looking at the failures of others. Why we have a very popular breach that's going around with the SolarWinds breach. And one of the things that people are doing is people are trying to learn lessons. How did that happen? How could that have been prevented? How could we stop something like that from happening again? Right? And that's part of like offensive security education. So, but before we make any progress, let's give sort of like a disclaimer. As at June of 2017, Microsoft no longer requires organizations to obtain a pre-approval to conduct a penetration test against their Azure resources. But it's important to also note that need the need or the exemption to not put in a pre-approval, that only applies to Azure. That doesn't cover things like Office 365 or Dynamics 365. So keep that in mind. It's also important to note that even though we may not need to inform Microsoft ahead of time when we are conducting a pen testing of our environment and our applications, we also have boundaries that we have to stay within those boundaries. We have to comply with certain rules of engagement when we're doing any pen testing activity in Azure. And failure to comply with the rules of engagement can lead to accounts being suspended or terminated by Microsoft, legal action being brought against us by Microsoft, or even financial claims being made against us by Microsoft. So let's be aware of that. My recommendation to you is to go to the URL that you're looking at on your screen right now. And that URL contains the guidelines for the rules of engagement. But I'll give you sort of like a general guideline in this video. So here's the general guideline. Any activity that can impact other Azure customers, or any activity that can impact the stability of the underlying Azure infrastructure is not allowed. So what does that mean? What that means is things like scanning the assets that belongs to another Azure customer, gaining access to data that doesn't belong to you, performing any type of denial of service attack, that's not allowed. That's a no-no when it comes to Azure, because that can impact the stability of the underlying infrastructure, which is also going to impact on other customers, and you're not allowed to do that. You're also not allowed to phish or conduct social engineering exercise against Microsoft employees, right? That goes without saying, but you're not allowed to do that. So what exactly are we allowed to do? So we're allowed to test our Azure endpoint and the application that we are hosted on Azure. That's very important. So we're only scanning and testing resources and services that belongs to us, and we're only doing it in a way that does not impact another customer. So things like just scanning endpoints where we've hosted our applications in Azure, detecting vulnerabilities in our configuration, that's fine. So, but before we also go further, it's important for us to have a broad overview of what the Azure platform is about, because that's going to guide us, that's going to help us to be more effective when we conduct pen testing. So let's do a quick review of the Azure platform. So the Azure platform is actually not a single cloud. The Azure platform is actually 4 different clouds, right? So we actually have Azure Public, we have the Azure US government, we have Azure Germany, and we have Azure China. So those are the 4 different Azure cloud platforms that we have. And the thing about these platforms is they are separated not only physically, but also logically, which means they have different management endpoints. We'll see that in the upcoming slides. When it comes to the scale of Azure, Azure Public has about 42 regions. The US government has about 7 regions. Azure Germany has 2 regions. Azure China has 4 regions. And Microsoft has announced 11 new regions that they are currently building. I believe that some of them actually became available more recently. Out of all these regions that we have, there's something called availability zones, which means the ability to decide which data center our resources are going to live in Azure. And as at the last time when I checked this, only 16 regions in Azure has support for availability zone. But that being said, there's actually another Azure platform that we could have, which is Azure Stack. So this is where we can do our own Azure environment, self-hosted in a hyper-converged infrastructure, and that could be hosted, but it has the same API and it's running the same software that runs the Azure platform. So let's have a look at the implications of what we've talked about. So the implication of this is that the management endpoints, like we said, they are logically separated when we're looking at the platforms. So when you're doing pen testing, you have to be clear as to which environment or which platform is it that your customer has resources, right? Or your client has resources. So they have resources in only Azure Public. The endpoints are different. So for example, the endpoint for resource management for Azure Public, it's what you're looking at on the screen now, right? That's management.azure.com. For Azure AD, that's graph.windows.net. But if you look at Azure China, you notice that the management endpoint and the Azure AD endpoint are different, right? And it's the same for Azure Germany. You can see that it has a different management endpoint. It has a different Azure AD endpoint. And the US government also has a different management endpoint and different Azure AD endpoint. Okay, so let's move on very quickly. We want to get to the real cool stuff, the demos. So in order for us to understand the Azure architecture, it's important for us to understand the methods to interact with that platform, because that's also important to us as pen testers, right? So these are the different ways that we can interact with the Azure platform. So using the Azure portal, using command line tools like Azure PowerShell or Azure CLI, or using just REST client. And if you're using something like Azure PowerShell or Azure CLI, you're communicating, you're using the Azure SDK. So essentially, these are just wrappers around the SDK. However, regardless of which tool that we're using to communicate with Azure, we're communicating with a single endpoint called Azure Resource Manager, right? So Azure Resource Manager is the single management endpoint for the Azure platform. So, and Azure Resource Manager uses Azure AD for authentication. So in order for you to be able to have any management access to Azure, you have to authenticate to Azure AD, either using a user account, a service principal, or a managed identity. And then you'll be able to communicate with what are called resource providers, which are the different services responsible for different resource types in Azure, right? And the services themselves, some of them also support authentication with Azure AD on the data plane. So in other words, we can do authentication with Azure AD on the management plane, but also on the data plane for some of the services. Anyways, let's get to the interesting bit. When it comes to offensive security of Azure, or when we talk about offensive security in general, the MITRE framework usually comes up. And this is talking about a document that describes the tactics, the techniques, the procedures that attackers use against the Azure environment. So it's a globally accessible knowledge base of adversary tactics, techniques, and procedures. You can access the framework for Azure. You can access it by going to the URL that you can see on your screen. And this is what the current framework looks like as at today. So that's what it currently looks like. So that being said, I personally prefer using mine. So I'll go over to switch to my Azure attack matrix and show you like the things that we're going to be talking about. So when we talk about the Azure attack matrix, I want you to think about this like as objectives. These are the different objectives that an adversary will be looking to achieve in a victim's Azure environment. So we have things like discovery. And discovery is referring to an attacker has the aim to learn about the victim's environment. Let's identify what the attack surface is. Let's gather as much information as possible. Let's build a profile of the organization. What cloud accounts do they have? What services do they have in those cloud accounts? How are those services configured? What applications are hosted on those services? So those are the type of things that an attacker is trying to establish in the discovery phase. And there are two sides to discovery, as we'll see in the follow-up slide. So discovery could be done in an anonymous way. In other words, you're doing that from the perspective of an outsider that knows nothing about the victim's environment, right? So that's done in an anonymous way. Or it could also be, if let's say it's like a paid engagement, that could be a case where the client actually provides you with credentials into the Azure environment in an assumed breach scenario. And then with those credentials, you can conduct your pen testing. So anyways, let's go to some other point, and I'll move very quickly here. So we have credential access. So credential access is where an attacker is looking to gain access to account information. So things like usernames and password, tokens, or access tokens that has permission in the victim's Azure environment. And they could use different methods like guessing the credentials, or credential dumping, or keylogin malware, and just different methods that an attacker could use to access credentials for a customer's Azure environment. So we have initial access. So initial access, at this stage, what the attacker is trying to do is to exploit a weakness in the victim's environment in order to gain a foothold in the environment. So what weakness can we exploit, right? So that could range all the way from cloud credential compromise. That could be just a weak or a default credential that's used in a service. That could be application vulnerability. That could even be trusted relationship through a third party that's been given access into your environment. Then we have execution. So this is where an attacker is looking to run some code in the victim's environment. So typically you're seeing things like server-side request forgery. Azure services have some type of protection against basic SSRF type attacks, so as to do some type of validation before your services that you're hosting in Azure is able to communicate with the platform. So it has this sort of basic protection against that, but it's still something that happens. You have remote code execution, automation account runbook, or just accessing the resources and just executing code on them. Then we have privileged escalation. So this is where an attacker is looking to gain more access beyond what they currently have. So how can I improve the permissions that I'm able to do within this customer's environment? Maybe it's only read-only access at the moment. How can I escalate that to where I can begin to make modifications within the environment? Maybe I can begin to open some backdoors within the environment. So, and there are different techniques that an attacker can use to achieve those objectives. And we have defense evasion. So this is where an attacker is looking to ensure that they're not detected. Right? Dwell time is very important when we're talking about offensive security. Dwell time is the time from when an attacker gains a foothold in the environment to when their activities are detected and they're kicked out of the environment. Right? So the longer the dwell time, then the more auditing and scrubbing that you need to do, because the attacker essentially has sufficient time to really move around your network and your Azure infrastructure and your Azure environment, and you have no idea what they've planted. So you have to do like a proper audit to be able to identify what's happened in those cases. So what makes the difference from an attacking perspective as to how long the dwell time would be how good you have defense evasion, right? So that could be things like disabling security services or modifying the trusted list to allow the attacker's IP address. The other one that's very interesting also is is targeting unused cloud regions. I'll give you a good example of that. So, for example, if you have like Azure, if you're using Azure Network Watcher, you'll be familiar with a feature called NSG Flow Logs, which allows you to be able to enable login for your network security groups, collect all those network logs, and then perform some analysis on them. However, not all regions in Azure currently has Network Watcher support, right? So which means if an attacker has this sort of information, an attacker could then target to deploy resources into those regions, knowing that you can't enable NSG Flow Logs, and it's going to be much more difficult for you to detect the activity from a network perspective. So anyways, let's move on very quickly. We have lateral movement, which is where an attacker maybe has been able to compromise a resource, but they're looking to compromise even more resources within the environment, and they have different techniques that are used. A good one is where an attacker is essentially trying to, or they've gained a credential and they're going to start accessing the Kubernetes API and then begin to pivot into the workloads that you actually have deployed in the environment. So let's clear all of that. Okay, so let's move on to that. Okay, so then we have persistence. So this is where an attacker is trying to persist the activity in the environment, and they're trying to say, if you're able to detect my activity and kick me out of the environment, how can I be able to gain access even after you've kicked out my initial method of access, of entry into your environment? So essentially that's talking about trying to plant like a backdoor into the environment, so to speak. And then we have the impact, which is where the attacker is looking to cause real damages, whether that's data destruction, whether that's data exfiltration, database dumping, denial of service attack, hijacking your resources, crypto mining, whatever that is, they're trying to get some kind of impact against your environment. So what I'll be doing today is I'll just touch on a few of these, because you can see that there's a lot of them. However, if you're not yet following me on YouTube, follow me on YouTube, subscribe to my YouTube channel, because what I'm going to be doing is every single technique that you're seeing on the screen, starting from the beginning of next year, I'll actually be diving into each of them very slowly and very carefully. So if you're interested in that sort of information, make sure you subscribe to my YouTube channel so that you can get notified when I put out these videos. Okay, so let's look at the discovery, right? So this is where an attacker again is trying to learn about the environment. And so, for example, like we have the cloud provider IP range scan. With Microsoft Azure, Microsoft publishes the IP address range of the Azure platform, the different regions, the different services. They publish a JSON file and they keep it up to date weekly, and that's available for anyone to download. What an attacker could do from an anonymous perspective, so this is not an assume preach situation, but from an anonymous perspective, an attacker could download that JSON file and then scan those IP address ranges, right? So scan the IP address ranges for virtual machines in UK South and learn what services are listening. That's not encouraged by Microsoft for you to scan IP addresses that don't belong to you. If you're in an engagement with a client, you probably want to get the client to give you a list of the IP addresses that are currently allocated to their environment, and then you can target those. But then an attacker could then essentially just run a scan using those IP addresses and identify what services are listening on those IP addresses, what ports are opening, what ports are open, and then with that information begin to look for vulnerabilities. Right, so that's one way to discover in an anonymous way. Another way to discover in an anonymous way is using, and by the way, if you see me look into the side, that's because I've got like this draw screen and I'm trying to have a look at the large presentation on this other side. So anyways, but the IP address is usually more effective when we're talking about infrastructure as a service, like virtual machines, virtual machine scale sets, Windows, virtual desktops. But when we are talking about cloud services, cloud platform services, you're typically doing some kind of DNS enumeration here. Now, the thing to understand about Azure platform services is that many of them use DNS suffixes that are owned and managed by Microsoft. And what that means is that when an Azure customer creates an instance of a platform service, Azure is going to assign that resource a subdomain of the associated DNS suffix. So for example, if I create a resource, the fully qualified domain name of that resource will be the resource name dot the service DNS suffix that Microsoft manages. So for example, if I create a storage account called Azure Offensive or a blob storage called Azure Offensive, it's going to be addressable to Azure Offensive.blob.core.windows.net. Right? And what attackers can then do from an anonymous perspective is to enumerate those DNS suffixes to detect what resources are actually active and what resources are available out there. So here's a list of some of the common services in Azure and some of the popular DNS suffixes that they use that an attacker could enumerate. Right? So these ones are important ones. So things like your Azure container instances, things like your Azure App Service. So these are like customer assigned public IP address. They could have DNS labels and an attacker could enumerate those. But we also have some of the other ones, so things like Azure Blob Storage, which is just object-based storage in Azure. So things like Redis Cache, just Azure SQL database. So an attacker could, for example, identify if you're running any database that's public in Azure and then see if you're using default or weak credentials, right? So there's a lot of services, and then again, an attacker could just target the DNS suffix and then do an enumeration of that to be able to identify services that are running out there. So when it comes to this, so I'll show you an example using a tool called MicroBurst in a minute. So with a storage account, like an Azure Blob service, you have storage accounts. Oh, what happened there? Okay, here we go. So storage account, when you're using like the Blob service of the Azure storage account, you have the storage account, you have your container, and then you have your object. And the addressable URL of your object should be the storage account.blob.core.windows.net / the container name / the object name. But what an attacker, or the other thing that's also important to know is that the permission can be configured to allow anonymous access. So somebody could have configured permissions on this container level to allow anonymous access. And there are two types of permissions that you really need to be worried about. And that's the blob permission and container permission. Blob permission means that someone that has the full address of the object can access it without having to authenticate. Container level access means they can list all the objects in the containers without having to authenticate, and they can also access the objects in that container without having to authenticate. So what an attacker could do is use DNS enumeration techniques, maybe in combination with DNS brute forcing, to be able to just scan and enumerate and detect available storage account, and run different types of names to be able to detect available containers. And then if container level access is allowed at that level, then what they could do is that they could then begin to dump out all the objects that you have. So a very good tool that's used for this is MicroBurst. So MicroBurst is an Azure pen test toolkit. It's a group of PowerShell scripts that can be used to perform different types of attack against Azure environment. So the creator is a guy called Carl Fossen. So very, very cool guy. So, and again, amazing tool that this is. So that's the GitHub repository that you're looking at on the screen. But what I'm going to do is I'm going to switch over to my demo environment, and I'm going to show you a demo of MicroBurst very quickly. So here I am in my demo environment here. So first thing I'm going to do is I'm going to download and install MicroBurst, right? So what I'm going to do is I'm going to run that command there to clone that GitHub repo. So let's copy that. Let's run that. And that's going to clone the repo. And if I do a list, I should have my MicroBurst repo that's been cloned now. So what I'm going to do is I'm going to do, oh, sorry, it's PowerShell. Let's clear the screen. Okay, what I'm going to do is I'm going to change my directory to MicroBurst. And I'm going to import the module or the functions of MicroBurst into my PowerShell session. So I'm going to import that. So once I've executed that, then what I can begin to do is I can begin to, first of all, discover services in an anonymous way. So let's say I have an engagement with a company called Spicy Crabs. And Spicy Crabs, I want to see if they've got anything that's out there. There is this nice script that MicroBurst has. So invoke enumerate Azure subdomains. So what it's going to do is it's going to enumerate those subdomains that we saw earlier. It's going to enumerate those subdomains and look for the base name and see if there's any services that's called by that name that's active out there. It's important to mention as I'm doing this also is that name does not necessarily mean ownership. So the fact that you see a name called Spicy Crab does not mean it belongs to the company called Spicy Crabs, right? Because anyone can create anything called Spicy Crab. So if you're in a paid engagement, make sure you confirm with your client if you found or discovered something, whether that actually belongs to them. Make sure you do not impact other Azure customers. Okay, let's move on very quickly. I'm looking at the time. So if I run that, so MicroBurst will begin to enumerate the different domains. So you can see it's enumerating that domain and it's moving further. And it's moving further and it's checking all of those. And if it finds any resource that has the base name of Spicy Crabs, it's going to call that out to me to see if I identified that. So while it's doing that, I'll talk to you about what I'm going to be doing next. So the next one I'm going to be doing is, after MicroBurst has identified some domains that has their name in that, what I'm going to begin to do is I'm going to use this other function that MicroBurst has, invoke enumerate Azure blob, and I'm going to use that to try to detect if there are public containers in those storage accounts. Now, this storage account belongs to me, the one that I'm going to be enumerating, so I'm not going to be accessing someone else's account. So, but we're going to see what that looks like in a minute once MicroBurst has finished identifying those services. So again, this is anonymous discovery. And let's see how that works. And there we go. So MicroBurst has done its thing. And what it's done is it's identified certain services. So it's identified that there's an app service called spicycrabs.azure website that's active. And Azure App Service Management, Key Vault, Azure Blob. So it's identified a bunch of services that's available out there. So the one that's very interesting to me is this blob service, right? So now I know that that belongs to me, that doesn't belong to another customer. So again, from an anonymous perspective, I can use this other command of MicroBurst to begin to enumerate that and see if there's any public container that exists in it. And if there's any public containers, what are the objects that I can access from that? So if I run that against my environment now, so let's see what MicroBurst is going to come up with. And what it's doing is there's a list that's built into MicroBurst. So actually, you know what? While we're doing that, I'll show you that list. So if I bring up my file explorer, sorry, and if I go under permutations, you can see that there's some base permutations that MicroBurst is essentially just going to go through this list and see if there's any container that has any of those names that exist, and then it's going to try to enumerate them if they exist and if they're public, if they allow for public access. So you can also add your own custom names to the list if you wanted to do that. So that's absolutely fine to do that. So, but for now, if I go back, you can see that it identified that there's a public container called /private and a public container called /public, and it's identified the objects that exist in both containers. So now what we can then begin to do is we can begin to dump out all the data in those public containers and then begin to essentially just have a look at them, see if they've got anything interesting in them. So for example, can use that. So I'll just say download.csv. Yep, so it's downloaded the first one. And then if I just do notepad download.csv, and you can see that we've essentially dumped out a bunch of user information that we found in a public storage account that belongs to our client in this case. So very, very useful tool for this use case. So let's move on because of time, because I want to show you some other interesting demo before we bring everything to a close. So we can't really complete our talk about when we talk about enumerating platform services without talking about subdomain takeover, because that's something that you see that's also common these days. So subdomain takeover is where an attacker has discovered that there's a dangling DNS or a DNS that's pointing to an Azure resource that no longer exists, and then they can sort of claim that. So the way that it works is you have a victim's Azure environment. So in this case, the victim has a traffic manager resource called Spicy Crabs app content1.trafficmanager.net that's that's essentially managing the entry point for a backend app service instance. So in this case, the customer has or the client has a CNAME content1.spicycrabs.xyz that's pointing to that name, the DNS name of that resource. And then whenever a user goes to access that, they access through the CNAME, resolve the CNAME, which takes them to Traffic Manager, and then they access the resource. But what now happens is the customer deletes that resource. But the customer has now updated their DNS that's still pointing to the resource that's now deleted. So now we have a dangling DNS. And if an attacker begins to enumerate the DNS zone of this client, for example, and detects that they have certain CNAME that's pointing to Azure resources, and then begin to check out those Azure resources and realize that they're actually not resolving because they no longer exist, what an attacker could then do is an attacker could then go to set up their own Azure environment, deploy malicious content on a resource, create a traffic manager resource with that same name, and essentially take over that subdomain, so that whenever users goes to talk to that, they're going to be talking to the attacker's Azure subscription, the attacker's resource, and they're going to be downloading malicious content. So that's one that we've actually seen happen quite a few more recently. So just be aware of that. So anyways, let's bring this to a close. I'll just talk about one more because of the time that we have, and then we'll round up. So the other one I want to talk about, so let's move to initial access now. So we've talked about discovery, just anonymous enumeration using MicroBurst. What about initial access? So once you've discovered resources, you want to access the resources. When we're looking at something like cloud credential compromise is one of the popular entry points when we talk about this. And this is where an attacker is looking to steal a cloud credential in order to be able to access the management plane of Azure, that is Azure Resource Manager, or the data plane of Azure, that is the services themselves. So what identities or what credentials will an attacker be looking to compromise to allow them this types of access? So the main targets are usually an Azure AD user account, right? So still an Azure AD user account. Azure AD service principal, which are application identities, or an Azure AD issued access token. So this is where an authentication process has been completed. The identity now has a cached access token, and an attacker is looking to steal that access token. So what are the methods that they could use when it comes to this cloud credential compromise? So that could be targeting users and admins, maybe phishing attacks, installing malware on their endpoint and downloading their credentials from there, targeting DevOps system, looking for variables that are put in plain text, targeting admin workstation and looking to steal cached credential from there, targeting Azure hosted applications that have managed identities assigned to them and looking to steal access tokens from there. So what I'm going to show you very quickly, because of the time, is I'm going to show you credential theft from an admin workstation. So this is where an administrator authenticates to Azure AD. Azure AD gives them an access token that they can then use to access the Azure environment, but then the credential is cached on the admin workstation. So what an attacker could do if they're able to compromise that workstation is they can essentially copy the cached credential and then use that to essentially make calls to the victim's environment. So I'll show that to you very, very quickly. So in this case, I have a victim admin account. So you can see admin VM here. And over here, I've got, let me go over here. I've got the offensive Linux 02, which is the offensive account and I'm using. So what I'm going to do is I'm going to go to the victim's account. If I do AZ group list, you can see that the user is already authenticated and they can list resources. They have management access to this. However, if I do a list.azure, the access tokens that are cached locally on this machine, and there is the user's profile that's also local. So if an attacker is able to access the system either through malware or through any other means, so what I could do, for example, is what I'm going to do is I'm going to zip up this entire folder. And after zipping up this entire folder, what I'm going to do is I'm just going to upload that to an Azure blob storage. So I'm just going to exfiltrate that. And that's something that an attacker could do using malware. So I've exfiltrated that to an Azure storage. So if I go over to this environment, you can see I have a folder here set up called exfil. If I refresh that, that's the token that's just been stolen from an admin's account. So what we can then do is we can go to the attacker system right now. If I do an AZ group list, let's set that AZ group list. You can see that it's like you're not authenticated, what you're trying to do. So, but what we can do now is I can go down to download the credential that we stole from an admin account. So downloaded that. If I do a list, let's clear the screen. If I do a list, you can see that credential has now been downloaded. I can now extract that and just apply that to my system. And if I run that, so that's now applied to my system. If I clear the screen again. Now, if I run the AZ group list that failed earlier, now that's successful. So essentially, I'm now operating as that admin. And now that you have access as the admin, you can begin to do things like, who's the admin that this credential belongs to? You know, show me who I am. What permission does the admin has? And begin to do all those information. So what I'm going to do now is once you have this sort of credential, you can then begin to use another tool called a tool like StormSpotter to begin to enumerate the account. So StormSpotter is an Azure AD graphing tool. So sort of like the ways people have described this is Bloodhound for Azure. So once you have like a credential that's been stolen in terms of an offensive engagement, you can then begin to enumerate the account using StormSpotter and then collect all those information and then use that to map out how you can move further in your attack chain. So we can visualize the attack surface and we can see opportunities to pivot or to move laterally in the environment. So this was created by the Azure Red team themselves, and that's the GitHub repository for that. So the way that StormSpotter works is there are two sides to it. There's a client side, which is called Storm Collector, and there's a server side, which is called StormSpotter. So using the stolen credential, I'm going to run Storm Collector, and then what it's going to do is it's going to enumerate the Azure subscriptions and Azure AD tenants and collect all this information in a zipped file. And I can then import that zip file into the server, into StormSpotter, and then I can begin to gain this visibility of opportunities to pivot my attack within the environment. So that's what I'm going to go do now. So with the credential that I've now stolen, that now exists over here, so let's begin to now run StormSpotter against that. So what I'm going to do is I'm first of all going to download Storm Collector, which is the client side. So if I do a list, I can see that I've got Storm Collector there. So what I'm going to do is I'm going to unzip that very quickly. And once that unzips, then I can move into that directory. And what I'm going to do is I'm going to run that to essentially enumerate this victim's environment using the credential that we were able to get. So it's going to enumerate all this, the victim's environment, run that against Azure AD and the Azure subscription. And then once we have a result, I can upload that into an Azure blob storage and then go to download it on the server side of StormSpotter. So let's wait for that to finish. So it's finished now. So if I do a list, you can see the results there. So what I'm going to do is I'm going to copy that result zip file. I'm going to essentially set the name that I'm going to be calling that file. And I'm going to run that to essentially send this over to Azure Blob Storage. If I go back to my Azure Blob Storage, if I refresh this, I've got that file now. So what I can then do is I can then begin to, I can go to download this on the server side and then begin to see. So if I go back to, if I go to my Linux VM in this case, and I'll log into StormSpotter, the server side. So I'm not going to be saving it. So now I'm logged in, but I don't have any results. So what I'm going to do is I'm going to go download the results that I just uploaded. So save the file. So now that it's saved that file, I'm going to go back to StormSpotter. I'm going to go to Storm Collector Upload, go under the download folder and upload that. And once it's finished uploading that, you can see all the different information that exists. So a quick one, if you go under queries, there are some sample queries that we can use. So for example, if I want to say, show me all the different, so here's a good one. So all owner relationships is a good one. So I can copy that. And then I can go run that as a query, submit the query. Oh, am I missing something? Okay, so let's do all our back relationships. Let's do that. So let's see, paste that in there. Oh, I think something is not right here. So let's try that again. Oh, okay. So it looks as if my StormSpotter environment is broken. So I'll give it just one more go and see if that works. If that doesn't work out, I can go to, so initially let's refresh the screen. Let's give that another go. And let's click on Spot the Storm. So I'm logged in. Here we go. It was just having a little bit of a hiccup earlier. So let's go to run. So that's company administrator relationship, and then you can begin to see who has member of company administrator. So now we can begin to visualize things as graphs, and that's what we like as offensive security people. We want to visualize things as graphs. So if I submit that query, and this is very important information there. So let's go move things around a bit. So it's essentially specifying there's a subscription there. Certain people has owners to that. So I can see who has owner to that subscription. I can see who has contributor permissions to that. right? I can see, so essentially you can now begin to see, okay, so these people have this level of permission and this resource has this level of permission, and then how can we pivot activities in this victim's environment. So anyway, so hopefully that was useful to you. Hopefully you got some useful information from that. So what I'm going to do is I'm going to round up with just some other information here. So the information I'm going to round up with is talking about Prisma Cloud. So this is on the attacking side of things. There's also a defense side, right? So the defense side, usually you're looking at a tool like Prisma Cloud, which is a tool that's created by Palo Alto, an amazing tool that does essentially all the different capabilities that you're looking at on the screen. So things like the security posture management of your Azure subscriptions, but also the protection of your workloads. That includes your containerized application, whether you have containers running in Azure Kubernetes Service, whether you have containers running Azure Container Instances, Azure App Service, or Azure Functions. So you have that overall protection across all the different areas of your Azure environment, right? So you have to onboard your Azure account and onboard your workloads into it, and then Prisma Cloud can begin to protect it. What I'm going to be doing, if you've not yet followed my YouTube channel, make sure you do so, because what I'm going to be doing is I'm going to be going through all those different attack techniques that I listed in the matrix that I put together. I'm going to be going through that. And I'm also going to be showing you how Prisma Cloud defends that site, how you can essentially stop those attacks in their tracks from being successful and being able to detect like an active engagement almost immediately. So again, make sure that you follow my YouTube channel, and I'll be able to talk more about that. So Prisma Cloud can ingest your config metadata in Azure, your audit logs, your network flow logs, and it's going to allow you to be able to use that to essentially ask any sort of question against your Azure environment, right? Where you can say, can you tell me where all these different activities have occurred, and can you show me all this information that's occurred in my environment, right? And it also has like built-in machine learning algorithms that can identify any anomalies that's going on in your environment. Like some of the ones that I've done would have been flagged by Prisma Cloud to say that's not right in terms of the commands that I was running. So anyways, follow my YouTube channel and you'll be able to get the full gist over there. So I think I'm way I am above time in terms of what I want to cover. Again, thanks very much for watching this video. I hope you all have amazing holidays and have a wonderful Christmas. If you are not familiar with what my YouTube channel is, that's my YouTube channel on the screen over there. There is an Azure Meetup group that I also host, which is also focused on offensive security. So if you go to meetup.com, Azure Cloud Security Meetup group, make sure you join that group. I have a blog called azurehangout.com, and that's my Twitter profile. So thanks very much for watching this video, and I'll see you next time. Happy holidays, everyone.